Hello everyone. In today's lesson, we are going to discuss about a new topic whose name is index, or you can say indices and the laws of indices. Laws of indices. First of all, I will give you a brief description about some of the expressions, some of the terms which are very important to understand the whole concept. This is like a raised to the power b. This whole thing altogether is known as a power expression. When we talk about this indices, so we use this power expressions a lot. Here, if we talk about this whole thing, so this is a power expression. Right now, this power in this power expression, I can see two letters here. One is A and one is on the top right corner of this A, which is B. This A is known as the base. And this B, this is known as the index power, index value, or it can be considered as a power also, or it can be considered as an exponent also. So whenever we are writing one, like let's say I have written x to the power of 2, okay, so this is a power expression, hold together all the things together, x square, this is a power expression. This 2 is the index value, or it can be considered as power, or it can be considered as an exponent, and this x is the base. The index value is the index value of the base, power of the base x, or exponent of the base. And how do we pronounce this A, and I have written here B? This is considered as A to the power of B. A to the power of B, or you can consider it A raised to the power B raised to the power B. All the index laws, when I will be explaining you, I will use this kind of notations. I will be using a lot of power expressions because the laws will be applied on this index value. Okay, and this index value is always associated with certain base. Now I'm going to explain the first index law, and that says if you have x to the power a, this is the first expression, first power expression, and there is another power expression also, x to the power b. What I can see in these two power expressions, that the base is same. So this is a condition for this first law. When we talk about the first law of indices, so the bases should be same. Powers can be anything. A and B, they can be same or different, but the base should be same. Then only we can apply this law. Base should be same. So if I am multiplying these two power expressions, this is like a multiplication law of indices. So if I am multiplying two power expressions having the same base but different exponents or even same exponents, so we can convert it into a single power expression, and its power would be, or exponent will be now a plus b. Now see, these laws are basically something which is like a kind of simplification. For example, if in the lower classes we read like, okay, 2 plus 4, we never write 2 plus 4. Rather than that, we prefer to write 6. Same way, if in a question we see that there are two power expressions, x to the power a is multiplying with x to the power b, instead of writing two power expressions and then multiplication sign, we would rather prefer to write x to the power a plus b. It is very compact and the most simplified form. Okay, so in math, the simplification process is really, really important. And whenever we learn a new concept, we do that. If we learn about algebra, we learn about the different terms, and then we learn, okay, how to add, how to simplify. Same we do in the surds also. Same is here in the indices. So index laws are basically used to simplify the power expressions if there is more than one. So this is the first law. Now here, as I said, these important conditions that a and b can be same or different, where a and b are known as the exponent values. But this x that must be same. The bases must be same. And this law you can apply for two power expressions or even more. So for example, if I take another example, if we take x to the power of a times x to the power of b times x to the power of c, so this can also be equals to x to the power of a plus b plus c. The condition we have to check, the bases are same of all the power expressions. Yes. Is there any multiplication sign only in the between? Yes. Powers can be anything, so those powers will be added and we will be getting only one power expression. Here we have three power expressions and here we have a one power expression. PO here stands for like power expression, sorry, E. Okay. Now how this rule has been generated, let's talk about that. For example, I have x to the power of 2 multiplied by x to the power of 3. Now, in simple way, if let's say I have 2 square, that is 4. Basically, it means 2 multiplied by 2. If I have 3 to the power of 4, its meaning is 3 times 3 times 3 times 3. Now here we have x squared. The first power expression is x squared, which means it is x multiplied by x. And then there is a multiplication sign. And then we have x cubed, which means x multiplied by x multiplied by x. So we have 1, 2, 3, 4 and 5x in multiplication. And as we can write 2 square is 2 times 2, same way this expanded form, I can write it like 2 square. Similarly, if I have the expanded form x multiplied by x, multiplied by x, multiplied by x, and again multiplied by x. So instead of writing in expanded form, I can write it in a compact form as x to the power of 5. So what is happening here basically? The power expressions, the base were same. And if you just add these two exponent values, then also we are going to get 2 plus 3, 5. So therefore this rule came into the existence that if we have x to the power of a times x to the power of b, this will be x to the power of a plus b. Now let's do some examples. As I said that the basis should be same. So always remember, if let's say I have 2a raised to the power of 4 multiplied by a raised to the power of 5, I cannot do it like 2a raised to the power of 4 plus 5. It is not equal to. Reason why it is not equal to, because here the base is not just a, it is 2a, and here the base is a. They are not equal. They must be exactly equal. So let's say if we have a question 2a raised to the power of 4 times by 2a raised to the power of 5, here definitely we can write it 2a raised to the power of 4 plus 5, which is 2a raised to the power of 9. Because we have two terms here, 2a in multiplication, 2 and a, if you know the algebra. So you have to keep it in bracket. Because if you write this thing and one is 2a bracket close and then 9, they are not equal. Okay, this is a very important point. Most of the students get confused here. 2a to the power of 9, its meaning is 2 is multiplied by only a to the power of 9. Okay, and this 2a raised to the power 9 means it is 2a, first 2 is multiplied by a and then we are taking its power 9. Let's say a is 2. We assume a is 2. So in the first case, this one, here what we will do, 2 multiply by, or let's say take it as a 3. Okay. So if it is a 3, so it will be 2 times 3 to the power of 9. And here if you solve it, 2a to the power of 9, its meaning is 2 first multiply by 3 and then raised to the power of 9. So here it is 6 to the power of 9. So these two terms are different. So always remember, if you have more than one term in a bracket in multiplication, please always you have to use the brackets. Don't write 2, 8, 9. because this is not equal to 2a raised to the power of 9. This is the first law of indices. Now, for example, we have a question: x to the power of 9 times by x to the power of 1 over 2. So exponent values can be in fractions, they can be in decimals, that is not an issue. Only focus should be on the base. So these two power expressions and they are in multiplication. This is the second condition you have to check. Then you can convert it into x to the power of 9 plus 1 over 2, or you can write it like x to the power of 19 over 2. Now you can take second example. If I'm taking, I can take it x to the power of 9 times x to the power of negative 2. You can take negative exponent values as well. So here it will be x to the power of 9 plus negative 2, which means it is going to be 9 minus 2, and that is 7. So I tried to cover the first law of indices in this video, along with the definition of power expressions. What these terms are really, really important. You must understand the mathematical terms, how to say them, and what do they mean. Okay, in question, if you understand these terms, then it will be easy for you to crack the question. All right. Thank you.